Hi, I'm Heiko, Head of Product here at Memfault, and I would like to welcome anyone to our second Android webinar today. The previous webinar back in October is not a prerequisite for this, but it's certainly a recommendation. This is about our Android SDK called Bort and its new version 4.0. Well, Android. Android devices run on software, and as with any other software system, these devices will encounter bugs and demand unforeseen changes. And even if your software was flawless and complete, when shipping to hundreds of thousands of devices, there will be hardware issues. There will be edge cases. You know, the 1 in a million edge case you cannot reproduce in a lab, but your customers will. It's just a numbers game. Or to put it from a different angle, look at it from a different angle, all devices will have issues, probably the ones you have already shipped. You may not know it yet. And Memfault can give you the tools to not only notice them before your customers will, there are also plenty of ways to fix them before they will even notice. So back to Bort 4.0, we've been working hard to add a series of key updates to our SDK that together I think represent a quantum leap in the types of insights you can get from your fleet at scale. What kind of insights? Well, stay tuned. This is an overview of Memfault, our SDK, and what's new in 4.0. So here at Memfault, I help building this system because I'm convinced that good tools are the key to stay competitive. I've been in the software industry now for more than 20 years. This is a long time. And I was spending a good chunk of the last decade at well-known hardware companies. This is where the wrinkles come from and the gray hair. I believe that we can drastically improve how we build hardware products based on that experience. And I think we can do so by looking at the software industry to see how the software industry thinks about software products. Sounds weird, I know. I will get to that. And here at Memfault, I must say, I find great pleasure in help closing that gap where hardware companies become, more like software companies. Some shameless plug. Memfault is a global company. We have offices in SF, Boston, but also in Berlin. I'm in Germany right now. And we are hiring all over the globe. Check out our website and apply. Now on to the actual webinar. Looking at that title once more, Managing Android Devices at Scale with Memfault AOSP SDK Bort 4.0. That's a mouthful. If you have any idea what Bort means, please write it in the chat. I will send out stickers to whoever guessed that right. I can disclose that yesterday when I was asking that question internally, not everybody knew that answer, but we will get to that too. So let's decipher this title a little bit, shall we? Memfault. So yeah, well, I will give an overview of what Memfault actually is. That's part of this presentation. Android, I think that's a given. Devices. I want to call out that Memfault is not a system that collects log lines so that you can later search the logs with some Elasticsearch or anything, nor is it a dumping ground for bug report zip files that you can download and process locally. Memfault is a fleet management solution and an observability platform, and we really think of fleet and devices first and tie everything we collect around the notion of devices, and then we have other entities in our model that really are rich and not just plain unstructured data. And the 4.0, that's really just what's new and what we want to talk about. Let's look at the last 4 tokens of that title, AOSP SDK Bort 4.0. Now's your last chance to enter in the chat what Bort may mean. AOSP, I mean, the audience of this presentation should know, is the Android open source project. I want to call out that Memfault's SDK is meant for vendors, device vendors, not application developers. You can totally use it to inspect and add telemetry to your system apps and your apps that are part of your system image. And you can also collect the bugs that may occur in those apps. But the target audience of the SDK are device manufacturers that have control over the AOSP image that goes on those devices. SDK, software development kit, that means we have software that runs on those very devices. Yes. Memfault has an API, there's a backend, and there's also like a web page, like a web application around it. But the Bort SDK is software that runs on your devices. Now the reveal. Bort stands for bug report for historical reasons. I think when you first start collecting telemetry and crash reports for your devices, bug reports are a good first step towards that goal. Bort has since totally outgrew that, and oftentimes we recommend not to use bug reports. It's actually turned off by default now for good reasons. But the name Bort is obscure enough so that we can keep it, and we will not change that name anytime soon. And 4.0 really just means that we have been in this game for a while now. The SDK is battle proven. We have support for Android 8 Oreo. So that was the good old times when Android was named after cookie and candy. We still have like internal names like Red Velvet Cake. I particularly like the internal name for Android 13, Tiramisu, but now we count in numbers. So basically 4.0 means, yes, it's very mature. Let's go back to the previous webinar. We closed that webinar with mapping out different features. And then that's the x-axis. What would you need for a device management and observability platform? And it consists of debugging and monitoring and updating devices. And then we clustered it in different levels, the y-axis. We said some of this comes out of the box on AOSP, and other items you would need a special agent on the device for. Well, that's Bort. And then there's a backend part to collect all of this and a dashboard to present it. And basically we said all of this is covered by Memfault, hence the green color. And I was thinking, so now we have additions. Can we make it even more greener now that we do even more? No, we won't do that here. Instead, I chose these little star icons. So you will find that badge with a star whenever something is new due to Bort 4.0. For example, we now support Android 12. To my surprise, we said, we don't have to do that right away. But matter of fact is, we have customers already on Android 12. And so Bort does support it. Incremental updates is certainly a very high requested feature, and we now support that as well. But the actual, the logic of applying an incremental update is part of AOSP. We provide the update agent as part of Bort. And with Bort 4.0 come different new topics that Memfault as a whole supports, namely OTA management, device attributes, time series metrics, and then also some very advanced use cases. This list, Bort 4.0, and these 4 items are also partially the agenda or outline for this presentation. So I will talk about these items in this order. All right. To do that, I would like to take a step back and to the humble beginnings of writing code for AOSP. It starts with code. You are, as a software developer for Android, for your hardware devices, you are writing some code, and then from there you flash it on your device. You do some local testing and then some local debugging. And Android comes with a lot of great tools to support that workflow. I mean, there's ADB to deploy all of this and downloading it. Android Studio evolved a lot. I know like some of my coworkers at other companies where we did AOSP did the same work with Vim. That's also fine. But ultimately, you go through that cycle and you need to ship it. You need to ship it fleet-wide. And at that point, you cannot really use all these local tools anymore because they simply don't exist. You don't have physical access to all these devices. So I want to rearrange these elements a little bit. Deployment suddenly becomes you install your software not on your own test device or development board anymore. You deploy this in the field to tens of thousands, hundreds of thousands of end users you may not even have direct contact with. And you're not running and observing it, following a test plan. They are just using it, maybe in unintended ways. And how do you analyze what's happening? How do you even know that something happens? The coding part remains, and everything that previously was this cycle is condensed to test in this visualization. This visualization may look familiar to you. In the software world, oftentimes this very figure-8 infinity cycle is used to convey the idea of DevOps. You have on the left-hand side the development piece, you're writing code and you're testing it. And then on the right-hand side, you have the operations side. It's meant to operate always connected server clusters. But I think the same methodology applies well to a distributed fleet of embedded devices. But I want to call out that with this separation, you now have on the left-hand side local development that's at your desk, at your office. And then on the right-hand side, that's in the field. You have very little control over it, yet that is where the value is being created, the value of your product. Memfault focuses on anything that is depicted blue here. All of that is covered by Memfault. You keep engineering developing your software as you did before. Memfault supports you on all the operations side. At no point we do anything on the left-hand side, except integrating Bort. Bort is something that runs on your device, and therefore, at least once you need to alter something on your build. But in theory, this really only happens once and once only, until Bort 5.0 comes out, I guess. And after that, Memfault cares about anything on the right-hand side. So what is Bort then? This is, one of these normal fancy system architecture diagrams. In fact, this is straight from our docs. Memfault is multiple components that rely on standard AOSP stuff, like the Dropbox manager or bug reports. And it's a few very minimalistic additional services and apps. And that may sound scary in the beginning. Why is it so many? That's for good reasons. This is to apply best practices in terms of security and privacy. This is like we are implementing the least privileged access methodology. Also, every single piece is as simple as possible. And because everything is configurable and optional, you can trim it down to really only what you want. This architecture really leads to this design ultimately. There are only a few points where Memfault contributes to the AOSP image. Anything that has Memfault in the name is basically it. And with Bort 4.0, we have two additions. There's the Memfault Update agent. That's just a daemon that talks to the cloud to receive updates, incremental or full system updates. And then I wrote update service here. This is basically recovery system or the update engine from AOSP. So like all the integrity checks, actually doing the A/B update or the seamless update, validating certificates. All of that is just inside, Memfault, nothing to do with it. Memfault orchestrates that, that's all. And the other one is on the right-hand side, the Memfault metric service. And that is really embracing a huge addition to this Bort 4.0 SDK, the ability to collect metric reports. And we will later learn what this is good for, but ultimately it leads to fleet segmentation and insights in your broader fleet, but also on a per device basis to do inventory management. You can then correlate, crashes with particular driver versions or track product specific KPIs. Right. I think it's time for our first poll. Before I go through the different items hands-on to show you how that looks like, I want to bring up our first poll, which is, do you collect bug reports today? I think I'm not sure if Colleen has started the poll already. It looks like it. Colleen, can you put in the chat if you did that already? So the idea here being, it's launched. Okay, so the idea here being bug reports are a great source for all kinds of insights. So if you today have the ability to trigger bug reports, maybe with a button in your Android application, like some user-facing application, sometimes it's like a double press of some hardware button. You could then trigger a bug report, and it contains everything under the sun, which is kind of problematic. It's not only large and it bogs down the system, but also it contains a lot of questionable data in terms of privacy. But it's a very powerful tool in the end. So I think we have more than 60% of people participating right now. That's good. So I see that basically the majority does not use bug reports. And then there's a tie between yes via Memfault and yes with another solution. So I hear that 50% are not doing it at all. The other half is familiar with bug reports and is collecting them. That's good. I will use that when I'm walking you through what Memfault does. So let's start first with how do you get started with Memfault? This is, I know that some of you are existing Memfault customers. This is probably not too interesting for you, but you may learn one or two tricks as well. It's basically trying to explain how simple it is to integrate. So it starts with going to docs.memfault.com. And if you click on the Android category up here, you will see an overview section. This is the same diagram we saw a minute ago. And then if you go to the Getting Started page, that's really a very hands-on, very detailed description of the steps you have to perform in order to integrate Memfault. Memfault's source code is available on GitHub. You can read it, you can change it. We intentionally don't share Bort. We're not sharing it as a Gradle library so that you don't pull in some black box dependencies. Rather, we want you to actively deal with that source code. You can, we recommend patching AOSP to get a couple of more insights. Some customers don't do that for good reasons as well. And then you basically integrate it into the build. We explain you how to sign the individual pieces. There are scripts that you can then later on to validate if the integration happens successfully, and then you enable that. And there's even like a troubleshooting section here. This is all there is. Like I was scrolling through this, it is very detailed, but it's not too complex. Some of our customers do this in an afternoon. And there's also a reference page that shows how you can fine tune all these elements. In fact, you can even fine tune it while it's in the field, but also you can opt out of many features if you don't want them, or if you decide to only do that later. So the TLDR is, it shouldn't take you long to integrate Bort into your existing build. And then what you get in return is, as soon as devices are reporting, is a Memfault dashboard that immediately, with the out-of-box experience, gives you insight into your fleet. It starts with the number of active devices over time, which software version they're running on. We immediately collect reboots and reboot reasons, new issues and crashes, and everything comes out of the box here. And from there, you can then drill down. So let's start with, I'm clicking on this particular one version I'm interested in. So there's this one device that was running on this version. It has been active here. I can broaden my search to look at even more devices. And if you happen to know which device you're looking for, say it's your one and dev board, you want to have more insights on, you can search for that particular device, pull it up, and then you can drill down in all the details. This one here, this is demo data. This is not real data. We made it a very crashy device. In practice, I hope you don't have devices that crash as often, but certainly that could be the case. And then you have all the kinds of like logs and stats you would know from Android if you were developing locally. So this is basically battery stats here. You can then drill down and you can see, what can you see here? This row I'm currently hovering on is the Wi-Fi signal strength. There's no signal, then the Wi-Fi supplicant kicks in. There's no Wi-Fi radio. Maybe the user turned off Wi-Fi, and then, yeah, and then it's good again. So you can basically look at all these numbers, and these are the built-in data points we are collecting for a device. The other perspective, very prominently positioned on the dashboard, are crashes and reboots and all of that. You can look at them either by clicking from here. We sort them by frequency, which one of those are the most critical ones, but you can also search for them in case you care about one particular one. So let's look at, like here, we see that 15 devices encounter the same problem here. You see the backtrace, you see the logs, and then you can try to triage this problem as if you had the same information locally. And since half of you are using bug reports today, I want to show you how that would look like in Memfault, even though we discourage people to use bug reports. So here's a seg fault. That's a native piece of code. So C++, there's a backtrace you see. Basically, what you're looking at is really just what you would normally get from that zip file that represents the bug report file. With all the different, the folder structure and the nested files within, you can still download it. And what we do is we present it in a nicer form. I'm sure those of you who have dealt with bug reports in the past have built their own little scripts to analyze bug reports, or they are grabbing through the text files. We basically make that more convenient. You can look at all the different logs from like event logs, kernel logs, and so forth. You can filter them, grab them. We capture what kind of, or present how the system props look like, what kind of packages had been installed. We derive the data points from the bug report as well, and print them in a nice form. This is not anything special. I mean, all the data come from a bug report. Is really just a nicer representation. There are better ways to do that, but since you know bug reports and you are using it today, you can continue using them. And with Memfault, you would have a lot of comfort or a convenience dealing with them. All right, with an eye on the clock, I'm going back to the slides where I am skipping over the summary because you heard all of that, but later on you will receive a copy of the decks. So that might be convenient for you as well. So in this setup now, we believe that we have integrated all the Bort with its default configuration. And that will give you everything and more what you've seen here a second ago. That's great. How about the first Bort 4.0 edition, which is incremental updates? Incremental updates are no different from, or are treated processed out of the box by our update agent. There's nothing special you have to do on Bort. So if you're asking what needs to be done on Bort 4.0, the answer is nothing. The actual management of OTA is done with the Memfault platform. So let me show you how that looks like. I do have a different instance here where I want to walk you through that. It's a different demo project. There are no issues. This is purely about different software versions and devices. So same setup, you can click on all these overviews and you can look at devices. But if you are managing OTA, you need different tools. There are not only devices, there are also ways to segment your fleet and describe different populations of devices. And one of those are cohorts. So cohorts are a way primarily to manage OTA. You can think of it as a way to structure different devices that you want to test, deploy something on. It could be like an internal cohort where you run bleeding edge code. There could be a nightly cohort that updates all the devices with whatever is top of main branch every night. There could be a beta tester cohort, but ultimately there will be one production cohort, and that's called default over here. Within the cohort, you have the same statistics you normally see fleet-wide, and a tool to manage updates, in particular, the special arrangements you need for Android, is the version matrix, and that's depicted here. So this is, again, a demo project consisting only of a handful of devices. It's like 80 devices are in this cohort here. They currently report 3 different versions, 1.0, 1.1, and 2.0. There is no update configured, no OTA configured, and therefore the matrix reads as follows. For every row, there's also a corresponding column. Which version will these devices be on after they have received their next OTA update? And because there is no update, they will all remain on the version they're currently on. So let's assume you are activating a release for version 1.1. And you can do this. And the question is, where does that release come from? How does it know what kind of software to install? a best practice we recommend people doing is to hook that up with your build system. You already create and sign system image updates. And at that point, you can exercise one of Memfault's APIs to also register the corresponding software release. It consists of the payload. You can attach different attributes and which hardware version the build is meant for. This has been done in this demo project already. So what I'm doing for this cohort is I'm activating a release, a full system update that will get every device to 1.1. And if I do this, the matrix changes. I see that devices on 1.0 and 1.1 will ultimately end up on 1.1, either because they're updating or they will remain where they are. And ultimately, we will have more devices further to the right at higher versions. And then later on, as I'm activating version 2.0, we see what is typical for our customers. You have several rows. Some devices may not have been updated yet, but normally very few columns, typically one column, which is the target version the current cohort is configured with. So all these devices will end up at version 2.0. All these numbers are clickable, so you can literally see like these 16 devices, which devices are we talking about? I am now doing something specifically for this presentation. I'm moving all of these 80 devices over to a different cohort, the second example. And now they are part of the other cohort where I want to create a slightly more complex setup. So this cohort has been configured with an OTA release, a full release of 2.0 already. That means 1.0, 1.1 will all receive it already. 2.0 stays where it is. But there are some devices already on 2.1. Interesting. And now I'm applying what Google recommends for AOSP updates. They say do incremental updates to save bandwidth and battery. But every now and then only do a full update. We did that. 2.0 is a full update. And now I'm configuring a Delta release that leads us from 2.0 over to 2.1. I'm activating that. And the interesting piece is that the older devices here that are still on a 1.0 and 1.1 version, they will not jump directly to 2.1. They will first receive 2.0, and devices on 2.0 will go to 2.1. And now I'm also activating yet another Delta release, this time as a staged rollout. That is a mechanism that allows you to further do it, basically to reduce risk, reduce risk, not rolling it out to all customers at once, but staggered only to a subset. And then basically we randomly assign which device should receive these updates. Here, that's only one device. And ultimately, you can immediately see which devices should receive which version and so forth. And all these numbers are clickable and inspectable. So like this is the one device that will receive the version. You can get to that device. For that device, you can see which version it has received in the past and which one it is going to receive. And if that's still not enough detail, you can see the entire decision tree for it. So we provide like full transparency into the process of OTA. And as you will learn in a minute, together with device attributes and time series metrics, you can further quantify and inspect the success of your OTA. All right, let's talk about device attributes. The idea is that Memfault out of the box collects, especially on Android, very meaningful data points from connectivity over battery to like system utilization. But ultimately, you want to collect your own specific data unique to your product. And that's a key addition introduced with Bort 4.0. You do this with what we call a metric report. As always, I'm advocating you to go to our docs, which is interesting. Am I still live? Can somebody tell me if I can, in the chat maybe, or like anywhere, can somebody tell me if I'm still online? Okay, I see Kyle's raising their hand. I don't know what happened to docs.memfault.com. Let me check another browser, terminal. Can you reach docs.memfault.com? Huh. Okay. DNS problem. Well, let's see if the rest of the demo works. Works on Chrome. Okay, cool. Let me pull up Chrome. Docs, memfault.com, probably a hard-coded Google DNS. So Android, show must go on. We have custom metrics. So same thing, disclaimer, this only works with Bort 4.0. And then we introduced a new API. The idea is that you have metric reports, you configure named metrics really. It could be a counter or a distribution, and you give it data at whatever frequency, and at regular intervals, we pre-aggregate this on the device and send it up to the Memfault backend. All of this is configurable as always. It's fairly straightforward to use. You can also use it from your native applications. Ultimately, this is the Memfault metric service, which exposes this through Binder. And then what you end up with is, well, that still works, great, is a list of metrics that are known to Memfault that had been reported by the devices in the past. And for each of these devices, you can then configure what to do with the data that comes in. You can also configure additional metrics that are not reported by the device, but are managed by yourself. So here I'm creating this maintenance in maintenance, or here, not a Boolean, but here it's a string, the region. And these, you can think of this as custom fields for your fleet. So instead of searching for some of the built-in fields here, you can now say, I'm searching for the region and I'm looking for all the devices in the EU. How does that work exactly? Well, either the device knows where it is and has reported that, or you can look at all the device attributes and even modify that if you like. So if that was not meant to, or was never actually arriving from a device, you can now move it over to Canada, and then it's over there. So with device attributes, you open up a lot of interesting cases. You could, for example, say, let's go back to the search. I'm interested in, I call this in maintenance, right? In maintenance should be true. Okay, I manually set this earlier today. There's only one device that is currently in maintenance, but we can now take this and create what we call a device set. Currently in maintenance. And I save that. And what we have now is, see, practice run. I have a chart that shows me how many devices are at any given point in time currently in maintenance. And I can see that as a KPI, a single value KPI. These device sets are powered by our search. So anything that can be expressed in the search can be condensed to a device set. And this is next to cohort a different way to describe a subset of your fleet, a population. That could be anything. There are really interesting use cases, which I would like to come back to now. So that would be something like, we see battery issues. Is this related to a particular batch? Maybe there was one SKU of battery supplied batteries that are faulty, and we can now pinpoint it if we know what kind of batch your device is from. And that way you can better triage your incoming bugs to know how risky they are and how to prioritize bugs against others. And then also distribution by region, or if it's a device that is connected to others, different ways to segment your fleet and to ask questions. Last and not least, also for inventory management, this is in particular interesting because you can also pre-register devices with Memfault even before they talk to Memfault, say at the factory, and then you can see how many not yet activated devices you have, maybe alongside with that calibration data at the factory, so that you can later correlate that back to issues. All right, time for our second poll, which is, do you currently collect metrics? I'm putting this up right now. And so with metrics, we understand numerical values typically, or enums, something that is not a log line or a crash, but something telemetry, something you want to know more about as a data point. And then oftentimes you use this in the context of time series, where you want to look over historical data per device, but also across the fleet. What's the average CPU consumption? Or say you have a product that can do nothing, but it offers a button you can press. How often was that button pressed? From that you could derive when it's time for maintenance, or maybe if people stop pressing the button, something else goes wrong. So I see that most of you are not using metrics. So like half of you are not using metrics, 30% only some system-wide metrics. That's basically what Memfault does out of the box. 12% say everything collects telemetry. That's great. So at a former job, I was working at a company that is very a strong believer in data-driven decision-making, where there were like telemetry for everything. It's an interesting set of data you have at your disposal at that point. We do metrics at Memfault, time series metrics in particular, where you can then ask over the course of time how a certain number progresses, not only for a single device, but also aggregated across the fleet. And again, if you ask me what you need to do on Bort, the answer is nothing you don't know already. The same system we learned about a minute ago to send metrics from the device, attributes, is used for time series metrics as well. We're short of time here. Basically, what this leads to is charts. You have charts, you can configure alerts, and ultimately you get fleet-wide insights. I'm pretty sure you are familiar with the general ideas. I would rather like to spend the time to talk about a few interesting use cases, especially if you combine this with attributes. You end up with questions like devices that were charged for more than 90% in the past week. Basically, they have been fully charged and are now below 10, have a battery problem. Or you could also combine it with reboot reasons. You know what, let me actually do this particular example. So I have a different project here, it has different metrics, but it's battery percent. I'm asking the search if in the last week the battery percentage was above 90. So that's plenty of devices. And then for another time range, this time only a single day. So yesterday, did it reboot because of low power? And the answer is yes, there are 3 devices. That's great. So those are devices that run through that battery within a week. This is not according to our product goals. One of them is a dev board. Let me exclude that and only look at prototypes. Great. And now I can save that again as a device set. I can see the trend and then later compare that against reference populations. So that's the general idea. Fairly powerful once the data is collected and available in the system. One very advanced new use case is possible with Bort 4.0, and that is the ability to treat multiple devices as a single user-facing product, which also includes a way to for the connected devices to use a dedicated gateway device as a hub, as a connectivity hub to the cloud. So one use case could be, for example, a point of sale system where you have a gateway device, a larger tablet, like an Android tablet that runs Bort as normal. And then you have maybe another payment terminal that is the end user is using to put in their credit card, which also runs Android, but for security reasons and also to save cost, maybe there's no Wi-Fi in it. They are still connected already so that you can actually see if somebody pays. But it's a proprietary protocol. And now you can use that channel and still use Memfault with all these enhanced security requirements to identify crashes, because they often go, if they occur, hand in hand. One way to look at them is through a feature which we call time sync. And maybe if there's later a question, I can come back to that. But for the sake of time, I will only tease you here. The idea is that you may see this here in the screenshot. There's a way to go from one device to another with just clicking at it. We use, again, device attributes to describe which devices belong to each other. And then you can put all your Memfault windows into a mode called time sync, where selections of time and zoom levels are mirrored to the other browser windows. So if you are drilling down on a particular time window, the other browser windows reflect that perfectly. Whew. So those were the additions introduced through Bort 4.0. And I would like to scale back to the big picture. We saw that DevOps cycle, where on the right-hand side, there's fleet operations, left-hand side, there's development. And I want to locate the different changes introduced through Bort 4.0. Like first and foremost, yay, there's now Android 12. We have incremental updates that's relevant for the deployment piece of your operations. There's device attributes and time series metrics to better operate and observe. I didn't mention really alerts, but instead of looking at charts every few minutes, you can also configure alerts that will inform you about outliers and certain target corridors your fleet don't match. And then you can now further analyze and debug even complex topologies of devices. And then again, the other perspective, where I'm looking at the different key aspects horizontally and the different layers, where everything is green and everything is great. Memfault ticks all the boxes to get you to the market faster with fewer bugs. Yes, that's only a fraction of the story, actually. Everything I've talked about is only a fraction of the story. Because in reality, the embedded world does not start and stop with Android. Android devices may be, brains of a scooter that is connected to microcontrollers that control the scooter hardware. Or, that Android tablet for payment, maybe that is connected to a microcontroller secure enclave for the actual card reading. There are many constellations like that. I was previously working at Oculus, where we had a VR headset running Android and two controllers on that ran microcontrollers with proprietary over-the-air communication. And when there was a bug, it was oftentimes with all three of them together. But it's not all just Android. Now, everything you saw earlier is also available for microcontrollers. And we are also expanding our support for Linux. And I expect all the features to exist also on Linux as well. As a result, Memfault provides a common platform for all your IoT devices, so that if you happen to have such a complex product consisting of a mix of Android and microcontroller and or Linux, or if your device interacts with devices from another department from your company, Memfault is in the unique position where this single platform can provide a common dashboard to manage your entire fleet and get insights across all these different platforms. All right, that concludes our second Android webinar. I hope you enjoyed this quick overview, basically a changelog and presentation form. At this point, I would like to send out a huge shout out to our Android team, as well as our customer support. You know who you are. Without you, this 4.0 release would not have been what it is. To you audience, after this webinar, you will receive an email with this recording, the slides, and some additional links. Among them, a link to the survey. The survey is also shared with you, I think, right now or right at the end. If nothing else, please click on that survey link. I'd love to learn more about your setups, as well as would like to know if you have interest in a follow-up webinar, and if so, on which topic. Okay, I think we have some time for questions. Be aware, I'm here at Memfault, I'm no longer an engineer. I'm a product manager. That means I may need to defer to some of our engineers for the deep technical questions. Colleen, do we have questions?
We don't have a lot coming out. There's one coming in. Can the metrics be filtered as all metrics may not apply to the device?
Yeah, you can in multiple ways. For any data point that comes in from the device, you can decide if it should be stored as time series metric to begin with. Everything is always visible on the device timeline. So on a per device view, that's always visible. You can decide that some of them should be aggregated across the fleet. But even if you do that, you can then drop certain data points. Oftentimes, values are only valid within a certain range. And if you blindly accept all values, for typical one is 0 means invalid value, or -1 or negative values. If you do that and you accept that and incorporate that into, say, the sum or the average, your data would be skewed. There is a way in the metric settings to configure exactly that.
Thank you, Heiko. The next question is, what are the most popular or useful custom metrics current customers are using?
This really depends on the product. It's a mix between technical metrics that we don't yet collect. In fact, some of our more recently added built-in metrics were informed by these custom metrics. And then it's also something that is product specific. So it's a gray area between technical metrics and then also product metrics. How often was the key functionality being triggered? If this is a camera operated product, how many minutes of camera feed did we actually collect? Or if this is, I mean, it really depends on the product. You have full control over which metrics to collect. For a while, the largest ask was around connectivity. I think we closed that gap to some extent, but being responsible for the product, I can never have enough functionality there, really. Yeah, and then also for Android customers, metrics are a fairly recent addition. So I've yet to see what our customers are going to do with it.
Awesome. Thank you, Heiko. The next question is, are there plans to allow Bort to be integrated with other custom backends? If not, does Memfault offer an on-premise solution?
Other backends, we have no immediate plans to connect to a different backend. So if you want to connect Memfault to your existing business intelligence solution, we do that with streamed exports. So Memfault is receiving the data, enhances it, parses it, and then immediately streams it out to your existing service. These are setups we see our customers doing. On-prem is nothing we have an existing offering for, as in this is exactly how you do it, but we have plans to support that. We are working with some of our customers on solutions like that, yes. It's not available right now, but if you are an existing customer or a potential one who's interested in on-prem, please reach out. We are happy to see what's possible there.
Okay, great. The next question is there a way to ensure no sensitive end user data ends up as metrics in Memfault?
Yeah, this is always a tricky question. First of all, privacy, I'm from Germany. Privacy is a valid concern and oftentimes an afterthought in modern software products, I feel. Memfault is very aware of privacy and security. So security, for example, anyway, like privacy, we do support scrubbing of personally identifiable information, PII, directly on the device, and you define which criteria should be applied. So the usual things is like passwords and other items will simply be scrubbed from the data you send up, and you have, again, full control over what should be scrubbed. The reason why we advocate against bug reports is exactly that. It unconditionally collects the state of the entire system, and you have no control over what is being sent. So yeah, we do that. And then there's also another step in the backend that you can also apply before we store data, where we additionally scrub PII. Was there also a piece of security in that question, or was that mostly privacy, Colleen?
It's mostly about sensitive end user data, so more privacy.
Yeah. So like I would like to add here, this is always difficult to answer. It really depends on the product. So recently, we've been working with a customer in the smart home field, and it turns out that the room name, which is a fairly valuable piece of information of a smart home device, like think of device attributes, the room name is considered PII because it's a value like living room or like bedroom sounds generic enough, but people are free to enter something, and sometimes they put in their first name of the kids there. Memfault cannot know what kind of metric you're collecting, so ultimately you need to have the power to decide that or scrub that yourself according to your particular privacy needs.
Okay, great. I think you kind of answered some of or gave some examples of this, but the next question was, could you present some real life examples for Caliper?
Caliper is almost as, so we are using the same features that Bug Report is using under the hood. Like it's basically dump sys and like Dropbox Manager. There's no difference between Bug Report and Caliper, except that Caliper is more configurable. That's the theory. In practice, it is not supporting everything that Bug Report does today, but we are trying to close that gap. So I'm not exactly sure what the question is aiming at. It should be, in theory, like if it was exactly how we wanted it to be, it is as powerful as Bug Reports, with you being in control which pieces you ultimately want to send up.
Okay, great. And the next question is, if I understood correctly, you mentioned that you discourage people from using the bug reports. Can you please elaborate on this?
Yes, so it's control over PII and control over bandwidth, and then also ultimately control over system load. So triggering a bug report, depending on your performance requirements, could bog down the system for a second or so. Anecdotally, again, at Oculus, we used bug reports, and I think you still can as an end user. And when you do that through a like special button combination, the entire VR experience that ran at 60 or 90 hertz to create that visual illusion was stuttering. And as a result, it's good if you want to capture a particular bug, but as a regular system mechanism to collect periodic events, it's wasteful on like different levels, storage, CPU, and risky from a privacy perspective.
Okay, great. The next question is it possible to create a custom distribution metric for specific percentile value? Example, P99 for Wi-Fi connection time.
Not with a chart today. We want, our customers want that, we want that. We want to provide way more insights based on the data we have previously collected. There's no single, create me a distribution graph and then the P99 slice from it. Right now, there are workarounds if you don't want to do this fleet-wide, but per device, where you do the pre-aggregation on the device. But fleet-wide right now, you would need to do some post-processing. If this is an existing customer asking for this, we sometimes do customer-specific charts. The general answer would be, we are going to get there, but currently there's no like single button to produce such a chart.
Okay, thank you. The next question is, do you know an example that Memfault system is running on an Android mobile phone?
Yes, but we cannot, like, we have a lot of customers that are well known and used by probably a good percentage of the audience on the call, but we only disclose customer names if we have agreement. So yes, Memfault can run on a mobile phone.
Great. I think that's all of our questions now. Unless anyone, we'll wait a few more minutes if anyone has any more. All right, here's one. How much memory does Memfault take on my device?
It depends. We get that question a lot. Memory, CPU, battery, storage, it's so highly configurable that you cannot simply tell. For all practical reasons, it's basically irrelevant. There is a storage aspect to it. When the device does not have connectivity, we persist data on the device until we have connectivity, not in RAM. So basically, you are limited by the amount of storage you assign to Memfault. Like when you do that, you may run out of storage, so you will lose data if you don't have connectivity. So yeah, basically the answer is you need to measure that yourself. There are many aspects that influence that very question. Like if like power for RAM, for example, like it really, yeah, that you need to measure that. I'm sure if you wonder about the last few kilobytes and of your system, you have already tools in place to measure that. I would encourage you to integrate it. You can do this in a matter of hours, I would say, and measure yourself how in your particular setup the system will be affected by our agents.
Thank you, Heiko. I think that was the last question. We're almost at time. I'll wait another minute or two if there's any other questions. If not, and you think of one later, feel free to email Heiko or myself or anyone, and we'll make sure to get you an answer.
All right, seems as if people are dropping off. Then I'm saying thank you again, and bis zum nächsten Mal.
Thank you, Heiko, and thank you everyone again for joining.